Hello everyone. Today on Tinkering with Terrius, I wanted to take a look at the 555 timer again, but today instead of the astable state of the 555 timer, we are going to look at the monostable state of the 555 timer. So as I showed in the last episode here, when the 555 timer is run in astable mode, it oscillates between sinking and sourcing current, and in astable mode, the oscillation time is based on the charge resistor, the discharge resistor, and the capacitor. In the monostable state, the 555 timer waits for the trigger of the 555 timer to be pulled to ground or pulled low, and the clock tick duration is based on the resistor R1 and capacitor C1. So just like before, we have the pin 1 going to ground because that's the ground pin. The control pin, which is pin 5 in the monostable mode, goes to ground through a 10 nanofarad capacitor. I don't have any 10 nanofarad capacitors, so I'm using a 20 nanofarad capacitor. Pin 8 is VCC, so it gets put on the positive rail. The reset pin gets tied to the positive rail as well, so that it can't just randomly reset the chip. The discharge and threshold pins are tied together. They're then connected to VCC through a resistor, and then down to ground through a capacitor. The trigger input comes from pin 2. It comes over and it's tied to VCC through a pull-up resistor, which is going to be 10K. And then of course it's pulled down to ground whenever you press in the switch. As always, pin 3 is the output, so depending on whether or not it is waiting for an input, it will be either sinking current or it will be sourcing current. So it's not too complicated, and it doesn't take very many components to set it up into monostable mode. We should be able to put this together and start playing with it. We have it all put together here. Pin 1 is going to ground. Pin 2 is the trigger pin. It's coming over here to the switch. The switch is connected to VCC on the trigger side through a 10K resistor. It then goes to ground on the opposite side of the switch, so that when this button's pressed, it will pull the trigger pin low. Pin 3 here is the output. It comes over to these LEDs. One of these LEDs is set up so that when the chip is sinking current, it will turn on, and the other is set up so when it is sourcing current, it will turn on. The sinking current LED should be on whenever the chip is waiting for a trigger, and the sourcing should be on whenever the trigger has been pressed. Pin 4 is the reset pin, and that one goes directly to VCC. Pin 5 is the control pin, and it's going directly to ground through a 20 nanofarad capacitor in my case, but it's recommended to use a 10 nanofarad. This one's actually about 16 nanofarads according to the component tester. Pin 6 is the threshold pin, and it's connected here through a little tiny jumper directly to pin 7. Pin 7 has VCC coming in through a 100K resistor. Then from pin 7 we have a wire coming off to this capacitor here, to the positive side of the capacitor. And then pin 8 is just the VCC pin, so it's tied directly to VCC. So when pin 2 is pulled to ground, the internal comparator inside the 555 timer will detect this, and it will set the flip-flop from low state to high state. This will turn off the transistor that's connected to the discharge pin, which is pin 7, which removes the short circuit here that is preventing the capacitor from charging. So then the capacitor charges up through the resistor R1, which is this guy here, which is a 100K resistor, and it'll charge until the capacitor reaches the threshold voltage of pin 6, which is going to be 2/3 of whatever the voltage coming into the 555 timer is. When that happens, the comparator in there detects it and changes the states again, which reverses the flip-flop back to its original state, which sets the output to low, and the timer goes back to waiting for a trigger pulse to start the whole process over again. And we can demonstrate that. So you can see that the LED up here is connected to VCC through a 1K resistor, and then it's connected to the 555 timer on its negative side. So right now the 555 timer is sourcing current, which is what we would expect. And then when we press this button, this LED should turn off and this LED should turn on for 1 second, because we're using a 10 microfarad capacitor and a 100K charge resistor. So let's see what happens. And there you go. So once the charge has discharged, it goes back to its original state. And you can see if I press this and keep pressing, nothing happens. It doesn't keep re-triggering it. It will only trigger the once in the time period while the output is high. But if you do keep pressing the button really fast, it will skip over that state. Now you might think that that's quite a long time for the LED to be on, so what we can do is we can change this resistor or we can change this capacitor. So the formula for determining how long this LED here is going to stay on for when we press the button is fairly simple. It's time equals 1.1 times R times C, with R referring to the charge resistor and C referring to, of course, the charge capacitor. So right now with the 100K resistor and the 10 microfarad capacitor, we're getting about 1.1 second delay theoretically, plus or minus a little bit of tolerance on both of these components. But I also have a 51K resistor here, so we'll swap out this guy and see what happens. You can see it's about half the amount of time the light's on for. So this can be a kind of handy way to debounce a switch, fairly complex way to debounce a switch, but it is one way that you can use a 555 timer to make sure that with the switch it only sends one output to the device that you want to switch. You don't have to have something connected when this is syncing current. I did that so there would be a visual so that you could see what exactly is going on when we press the button. So you can take the oscilloscope here and we can check and see what's happening with the output. So you can see here that the voltage of the LED on the output is 1.12 volts because we're getting 3 volts into the LED here. When we press the button over there on the 555 timer, you can see the spike happens. So it's starting at 1 volt and it's spiking up by 2 volts. So it's saying the maximum it's hitting is 3.5 volts. And you can see it's 1, 2, 3 divisions wide, and each of those divisions is 0.2 seconds. So this is going for about 0.6 seconds, which is roughly what you would expect based on the calculations. That's roughly half of 1.1 seconds. And to confirm that it's working how we expect it to, we can swap out that resistor again. Back to the much higher value resistor. You can see it's lasting for almost exactly twice as long. So it's got 6 divisions wide. It's still going up by the same amount. So I hope you enjoyed this little 555 timer video. I hope you learned something from it or found it interesting. So if you enjoyed this video, please like and share it. And if you haven't already, subscribe to my channel. If you have any questions or comments, or even ideas for future episodes of Tinkering with Terrius, then please consider leaving them in the section below, or you can email them to me or tweet them to me. Thank you for watching. I hope you have a wonderful day.